Welcome to the Masons Podcast, your source of insight and innovation in New Zealand building and construction. Each episode explores the products, systems and solutions that support trades, specifiers and developers to deliver high-quality, durable and efficient buildings across Aotearoa, New Zealand. From building envelope performance to flooring, acoustics and fire separation systems, we share practical knowledge and ideas that help shape the built environment.
Welcome back, everyone, to the Masons Podcast. Today, we're unpacking the Masons Enviro IT wall system, and we're really going to strip this back to basics. So if you're a designer, builder, or even a homeowner, and you've heard terms like AAC, intertenancy walls, or fire and acoustic separation, but you're not quite sure how it all comes together in the real world, well, this conversation should clear a lot of that up. So if you work with medium density housing, terraces or apartments, if you simply want a clearer understanding of how intertenancy walls are meant to function, we hope that this conversation will give you that context. Here we are with Arthur Whitfield again, Technical Manager of Masons New Zealand Limited. Good morning, Arthur.
Hi, Michelle.
To kick things off, AAC is one of those materials people may nod along to without really knowing what it is. So if you were explaining it to someone who's used to timber or steel framing, how would you describe AAC and what makes it different?
Yeah, so AAC stands for autoclaved aerated concrete. It's a concrete product with millions of air bubbles. So it could be described as foamed concrete. It's much lighter but less dense than traditional concrete and has various uses.
Great. Okay. It's not a brand new idea, is it? And there's a bit of history behind AAC.
Yeah.
Can you talk us through where it originated from and how it's been used overseas?
Sure. So some very clever Swedish guys in the early part of the last century developed this sort of foamed or lightweight concrete using aluminium powder and calcium hydroxide. And they basically brought about a reaction that foamed the concrete up. So you use a lot less Portland cement with a number of other elements to produce the lightweight concrete. Then in the 40s, you had Joseph Hebel from Germany, who basically perfected the embedding of steel reinforcing into the panels, which gave them a whole new range of uses. They became structural. You could use them for structural purposes because they had known structural properties.
Right.
So those were the development of AAC panels. And then progressively, the world over, people have used them for all sorts of applications: exterior walls, roofs, floors, partitions, and separations. They're good for fire and acoustic separations.
Extremely versatile. Looking at New Zealand projects specifically, where are you seeing AAC Enviro panels being used most often?
Yeah, so Enviro AAC is used for intertenancy walls, which we're going to talk about today. They're used for floors, for real premium, amazing feeling floors. They are also used in cladding systems, particularly with renders or plasters over them. Fencing is a common use. People like them for fencing in certain parts of the country.
Great. And Is there something behind the name Enviro?
Yes, so when the business first imported and distributed the product, they were aware of the fact that it uses a lot less Portland cement in its mix and therefore a lot less energy, because producing cement is very energy hungry. Also, it's a lot lighter. So that means there is less energy required to transport it around and ship it around globally and through the country. So that's why the name Enviro was chosen. We know that now that's a term that gets thrown around a lot, but that was the purpose behind it.
Right.
When we first launched it a long time ago.
A long time ago, sure.
Yeah.
So if you're using AAC panels within an intertenancy wall, it's got a lot to do. We've got to deal with acoustics, fire, structure and compliance. So when you look at all of that together, why does AAC work so well in that space?
AAC is an excellent insulator by its nature in terms of, for example, with fire, and it is also very, very good at stopping fire. It is non-combustible and it does a superb job of stopping fire for quite a long time. Also by its nature, it's the mixture of density and the millions of air bubbles. It's good at stopping certain frequencies travelling through it. Those sort of attributes of AAC make it perfect for fire and acoustic separation as part of an assembly.
And one question that comes up is whether systems like this are structural or not. Can the Enviro IT wall system be load-bearing?
Yes, not the central barrier material AAC by itself. It relies on the framing, either side of it. And everything that goes together, but the framing is the bit that bears the load. So let me just talk about that, because if people look at our materials online, you will see that there is the light steel framing intertenancy wall that is non-load bearing. What's happened there is that we have not done a full-scale fire test with load to determine whether the system can be load bearing.
Right.
We have done a full-scale fire test with the timber framing under load. And why this matters is because if, for example, you have two fire cells, fire cell A and fire cell B, if there is a fire in fire cell A and that becomes well involved and you burn out the linings and the framing in fire cell A, what we need is for the intertenancy wall to continue to support the structure and any load placed on it, perhaps with the roof structure, even with the framing on one side burnt out. So that's why it's really important to do a full-scale fire test under load.
And what about bracing of the intertenancy walls? Does the panel affect that at all?
The panel doesn't provide any bracing. If it did, we haven't tested for it. But you can get bracing from changing your standard 10mm jib to basically the jib product that is indicated in the jib manual for bracing, or by using the bracing calculator.
Great.
And obviously the nail patterns and anything else that's required by jib.
Yes.
So you can achieve bracing both sides of the wall very easily by following that.
Fabulous. So if someone's using this panel for the first time, what might they notice?
Sure. Well, I can remember as a young rep going onto a site in Christchurch and seeing somebody with a saw cutting through this, what looked like a piece of concrete on trestles. And I asked him what it was. And he told me it was a pebble panel. And what impressed me was how easy it was to work with the right tools. And then he just picked this up and took off with it across the site. And I was quite gobsmacked. Now, I know many people in the industry are familiar with it now, and it's probably not a novelty, but it's still got weight. And we'll talk about the weight of the panels and the need to plan lifts and that sort of thing later on. But compared to a piece of concrete, it's massively lighter. It is, of course, less dense.
Right.
And because of its steel reinforcement, you can do things like stick it across a couple of sawhorses or pick it up and hive off with it without it snapping or giving problems. So, and the other thing I would mention was that it can produce a bit of dust when you cut it. So that's something that people should plan for and manage. So that's probably the things that impressed me when I first came across the panel.
Okay, now let's take a closer look at the Enviro AAC IT wall system, which incorporates the AAC panel we've just discussed. Can you explain what this system is?
Sure. So the Enviro intertenancy wall system consists of a central barrier of 50mm Enviro ACC panels, which are mortared together with our Enviro glue. That's supported by aluminium clips. There's a 20mm gap, minimum 20mm gap, and then there's twin lines of framing, either timber or light cold rolled steel. We have double studs at 2.2 metre centres. Our panels are block stacked or stack bonded, one on top of each other, which surprises some people, but it does make for quite a low waste type installation. Inside of the framing, there will be insulation. It could be people's choice of glass wool or polyester. You could go to mineral wool if you wanted to, although there's no special reason in terms of the fire performance or even the acoustic performance. But, if that's your choice, you could do that. And then there is a minimum of 10mm standard plasterboard. I guess in New Zealand, we commonly call that jib because it's the best known brand. On top of that, you've got your finishes, your aesthetic finishes. But so working from the outside in, you start with your 10mm jib board, you have your framing, you have insulation, and that is for comfort. That is about managing the interior. Then you have got your air gap and your aluminium brackets, your central barrier. Underneath the central barrier, which is Enviro ACC panels mortared together, you have got a galvanized steel channel, which is bolted or screw bolted down to the concrete pad. And then you have the same assembly out the other side. Yeah. So it's a twin wall central barrier system.
Great. And how does it differ from other fire-rated intertenancy wall systems out there?
The Mason's Enviro intertenancy wall system, as you've heard me mention, is a central barrier system with framing either side and then wall linings, and fire clips and so forth. So there are other central barrier type systems on the market, and people will probably from their own research and their own knowledge of the market will understand the type of systems I'm talking about. They all work to similar principles. Then you have assemblies that are based on the incredible performance of gypsum board to hold back fire. And so you will have, double or triple skin type systems. They may be often both sides of a framing line, and they can be incredible fire performance. The acoustic performance can differ. We'll talk later on about the principles of how to achieve good acoustic separation. You also will have a poured concrete or poured in situ concrete fire separations or filled block fire separations, and all of these have different performance criteria. So there are, and then you've got your specialized timber-based product, some of these very heavy specialized timber panels. So there's a number of different fire separations out there. They all perhaps use slightly different ways of solving the problem. But what everyone's trying to do is to stop fire, heat, and smoke passing from one tenancy or fire cell into the other.
Into the next.
And the other thing they're trying to do is to stop noise traveling from one tenancy to the other, especially the frequencies that are really annoying to people. Absolutely. So that's what all fire and acoustic separations do. The other thing that people will be aware of or to consider is that these fire separations or intertenancy walls are rated in terms of their ability to stop, heat, smoke, flame, to keep their structural integrity, and also acoustic performance measures.
So with all these systems out there, why would someone choose the Masons Enviro IT wall system?
That's the million-dollar question, isn't it? The Enviro intertenancy wall system offers extremely high performance for the dollars spent to buy it and install it. So per square meter install, it basically charts very, very well. So it offers, if you have a light timber frame, you have FRR or fire resistance rating of 120, 120, 120. Now for typical residential, 3x3 townhouses or something like that, you only require 30 minutes FRR. So you're buying a huge amount of future-proofing.
Well exceeds it.
Yes, and also the minimum requirement in the New Zealand Building Code for the acoustic performance of the intertenancy wall, called the sound transmission class, which is a calculation, is 55. And you're allowed a little bit of a discount because on site, when installation happens, there can be other things that allow sound to transmit through the wall. So the Building Code allows for a further discount of 5. So our system is estimated to perform at 64 STC. So, even with the allowance on site for a little bit of degradation through unexpected things, through flanking and other sort of things, you're still well above the minimums.
So you won't drop below that, which is good.
And I emphasise for the performance, it's a very cost-effective system.
So Arthur, would it be correct in saying that the Enviro panel intertenancy wall system can be used in medium density housing, townhouses, terraces, duplexes, motels, or anything that requires an intertenancy wall?
Yes. The construction you've just mentioned is exactly what it's designed for. So buildings that are built under NZS 3604, up to a maximum of 10 metres. Typically, that's no more than 3 stories.
Okay, I'm going to dig a bit deeper into performance. Can you explain how the Enviro IT wall system handles fire separation between units and what that actually means?
Sure. So you've heard me mention that the Enviro AAC panel is really good at insulation, fire stopping, and obviously we talked about how it transfers sound or it stops the transfer of sound. So in the intertenancy wall system itself, if we're talking about 2 tenancies, so you've got tenancy A or fire cell A on one side, tenancy B, fire cell B on the other. What happens is if a fire starts up in fire cell A, tenancy A, we certainly hope the occupants have woken up, smoke alarms have woken them, they've been able to get out of that dwelling intact with their pets and, kids and all that sort of thing. So what we've got now is a fire which may or may not become involved, depending on a number of factors. So what happens is if that fire does become involved and gets up to a decent sort of a heat and conflagration, what will happen is the jib board will hold that fire back in fire cell A for quite some time. Jib board and plasterboard or gypsum board is amazing in terms of holding back fire. Eventually, fire will find its way through that board and then it will get into the framing and the air gap space in front of the Enviro AAC panel. What happens is the insulation will burn out and melt, the framing will burn out, the aluminium brackets will melt, and essentially, in the worst case scenario, the whole of tenancy A or the fire cell A will just completely burn out.
Yes.
Because of the nature of the wall and the nature of the AAC panel, the fire and the heat and the smoke will not get through the intertenancy wall and affect the people in tenancy B. And the whole purpose of the system is so that the people in the other tenancies can hear the fire alarms, gather up their pets and their children, their passports, and get out of the building safely. And, everybody can sort of get out in the car park.
Yes.
So that's the whole idea. So that's how it works. The idea is to contain the fire on one side of the firewall or the intertenancy wall.
Protect damage to the unit next door.
So between the jib board and the Enviro ASE panel, you've got at least 120 minutes of integrity in terms of no heat or smoke or flame getting through the central barrier. Those are the key things.
And it's done its job. It's slowed the spread.
That's right. Stability means that it will still be structurally sound, even if the structure or the framing on one side burns completely out. And insulation is this business about holding back heat and other aspects that would damage people on the other side of the intertenancy wall. You've heard me talk about FRR of 120, 120, 120. That is not the case for light steel. It's dash 90.
Okay. So why, Arthur, would it be a 90-minute rating for the steel compared to 120 for the timber?
So steel and timber behave differently under fire, with a well-involved fire and the high temperatures that are involved. So the reason why there's a dash in the dash 9090 is because we haven't done a full-scale fire test under load with light steel framing. The second part is that steel tends to lose its property, starts to soften and not be able to do its job structurally at certain temperatures, at certain stages in a fire. They both have very known properties. This is very well known to the structural engineers, the fire engineers, and that is why the difference. It's also to do with the amount of material. It's getting into sort of quite a specialised realm, but that is the fundamental reason.
And smoke's a major factor too, isn't it?
Huge. Yeah. Things I've learned by going to the NZ Fire conferences, which I really recommend to anybody in the building industry, is that smoke will do a lot of damage to people and it will do it early.
What about the acoustic side of things? Does it make a noticeable difference for people living next door? Is it more of a compliance tick box?
Right. There's sort of like 2 or even 3 parts to that. Is it a compliance tick box? It's certainly to do with compliance. And rightly, in this country, we have standards for the amount of noise that can travel through an intertenancy wall. You have separate tenancies. So the intertenancy wall is effectively like a boundary. So if I've bought Unit A, you've bought Unit B, you're practicing the drums, your kids are learning violin, and I want to enjoy peace and quiet, a really well-constructed, well-designed intertenancy wall is going to make a big difference to people's quiet enjoyment. It really does make a huge difference.
It does.
It also, compliance is obviously very important.
Yeah, and it's changed from 30, 40 years ago, hasn't it, where people are just living in closer proximity.
You certainly know when you're in an older building or a hotel where the construction doesn't lend itself to blocking noise through partitions, you certainly notice it.
Yeah.
And contrast, when you go to places where perhaps the construction or the designer has really thought about that and just how quiet and
really
peaceful
notice
it is.
Don't you? Right, let's talk about the system components that make up the Enviro IT wall. Can you tell us a bit about all of those, Arthur?
Yeah, sure. So I guess there's no surprise to people that the Enviro AAC 50mm panels are a key component. So 2200 millimeters long by 600 millimeters by 50 millimeters. So hero product. Then you need Enviro glue mortar or adhesive mortar to bond all of these panels together. And once that's done, you essentially have one piece of lightweight masonry. The steel channel, galvanized steel channel, screw bolts or donor bolts for the base of the wall, the all-important aluminium fire brackets, and then specific screws. We have screws that goes into the framing and then screws that go into the panel. They need to be exactly specific as per the system as they have been tested for performance. Sudal firecrol seals the galvanizing channel down to the concrete floor or the concrete pad. The insulation, the framing, and the gypsum board, which is typically going to be jib board, a minimum of 10 millimeter, unless you're using something else for bracing purposes or something along those lines. Right. And mineral wool for the fire seals, super important.
And how do all these components pull together to create the final wall?
Okay, the framing, very important part and something to watch if you are detailing the system for your clients or if you're a client that's interested in wanting the system in your job. Our system does require double studs at every 2.2 metre intervals, and that's because it's a stack bonded system. Stack bonded, why? Because it reduces waste in terms of cutting panel. But the trade-off is you do need 2.2 metre studs. One of the benefits is that you can go up to 3 metre high per story with your studs. So very important to get the framing right in the first place. Obviously, consider your jib board, your gypsum board. 10 millimetres is the minimum. If you want to go heavier or go to different specs, you can. Your insulation, that's for comfort. So you need to put in or call up what is the minimum required for comfortable spaces for walls.
Yep.
The aluminium fire brackets create the space between the framing line and the central barrier. So that airspace, that minimum of 20 millimetres, that's a crucial component in acoustic performance. So the principles of acoustic performance are mass and separation. So we get the mass from the central barrier, the Enviro AAC panel, to a degree, and we also get mass from the gypsum board.
Right.
Those two products provide mass. The separation comes with the air gap, and that's provided by the aluminium brackets. Now, because we have got physical connections between the central barrier and the framing, we have to have that for structural purposes and to hold it all together and make it behave itself. So when you've got a connection, sound can transfer.
Yeah,
so the game is to try and get the minimal number of physical connections between the central barrier and the framing while still providing enough structural performance. That's the trade-off.
Are there any variations in the system depending on whether it's a timber or steel framing or even building height?
Yes, okay. So the main variation would be if it is a light steel framing choice or call-up, that the screws used to fasten the fire brackets to the light steel framing are slightly shorter. And the major thing is that we don't offer a load-bearing system at this time with light.
You touched on that. Yeah,
so thanks. That's an important consideration. So if you're wanting to rest some of your trusses or roof load on the wall, well, you can't do it.
No.
You basically can't do it. So those are the two major considerations.
Okay.
And the fire rating is lower for light steel.
Let's switch over to design considerations. What should designers really be thinking about early on when specifying an intertenancy wall to make sure it, performs properly?
Right. So I've got to try and put myself in the position of a designer, put myself in your chair, Michelle, but it's like everything with building design. The building designer has to juggle the minimum requirements and what they can do to achieve greater than minimum requirement, budget,
cost,
buildability, access to the site. They have to think about footprint. So, for example, the intertenancy wall that we've been discussing and similar central barrier twin frame intertenancies walls, they're high performance, that they do demand a certain amount of footprint in the build. So that can have a bearing on the occupied space. So as you would know as a designer, there's so many things the designer juggles, including the client's expectations. So
and integration with other building systems too.
So it's probably difficult for me to answer, but the questions they would ask themselves would be, what degree of fire and acoustic separation do I have to have, and what would I like to have? Then how's it going to affect my occupied area or the space inside? And then if you've got difficult sites or you've got remote locations, there's also many factors. Like this system that we've been discussing today is pretty tolerant of construction moisture. So for example, you do not need to provide temporary cover or a temporary roof over the intertenancy wall once it's built, whilst you do other things during the build. So AAC panel and the components are very, very tolerant of construction moisture. Not talking about the gypsum board or the insulation. The mineral wall is always put in later anyway, but it's also quite tolerant of moisture. It doesn't need babying, and that may be a consideration if the designer's thinking about the construction sequencing and stuff.
How critical is it to make sure that everything is continuous with no gaps?
Pulling that apart. So the typical junctions that you've got are the concrete pad, so that's taken care of with the galvanised channel and the Cedal fiacryl. The junctions with the exterior cladding, the vertical cladding, that is a mineral wall, is compressed by 10%, is an incredibly important element. And often there is timber battens there as well for the known char rate. So you've got a belts and braces, to stop fire and smoke sneaking around the edges of the wall. And at the top, where it intersects with the roof decking or roof cladding, you've got carefully installed mineral wool again.
Mineral wool.
So those are the crucial junction details. And you mentioned no gaps. If there's one thing, people constructing this wall system or inspecting this wall system, an architect on site, an owner on site, if you can see a gap anywhere through our intertenancy wall or anyone else's intertenancy wall, it will not hold back smoke, flame, and heat. that's a problem. Or in sound. Any
Absolutely
sound will travel through
compromised.
any air gap, any hole, any gap.
At that stage, yes. No,
No
there
more
never
gaps.
should be. No more gaps.
No more gaps.
So are there any common mistakes that you see in construction that can cause issues later on?
Yeah, so you've already touched on one, which is gaps.
Yeah.
Absolutely. Under no circumstances, any gaps anywhere with the completed intertenancy wall, especially special attention to fire seals. Secondly, we've mentioned it earlier, and it's just something that could easily happen. And my plea to any project manager, construction manager is please make sure your teams installing this wall are using a clutched drill driver. That's written in all of our manuals, it's on our drawings, and that is downstream from testing that we have done, structural testing that we have done, and it works very well if people use the right settings with their drills.
What about limitations on the system? Does the designer have to keep within certain parameters when they're...
As with any proprietary system, yes. So go to our system manual, go to our system drawings. The big one is that you limit, if you call it a limitation, you've got to go have no more than 3 meters stud height.
Yeah.
And there is a limit to how far you can project past that for like a parapet or something. The framing is as it is set out in our system. So it must be double studs at every 2.2. Like there's no component swapping basically because it is a tested system and a reviewed system. There is no room for component swapping.
Okay, and talk to us about construction joints, Arthur.
Right, so construction joints are important in the system just to allow for a bit of movement over time or very small seismic movement. Running up and down the wall, if you think of it, running from the base
Vertical.
to the top of the wall, we're looking for a horizontal construction joint every 10th panel. So that's the panels are 600 millimeters wide, so that's every 6 meter spacing, near a mid-4. So where there typically might be some movement. And if we're going, along the intertenancy wall, a vertical construction joint, so a joint running from the concrete pad right up to where it joins the roof decking, we suggest that every 4th panel, 2.2 metre long panel, or 8.8 metre spacing, but it must occur after every 5th panel, 2.2 metres long. So that's
maximum, right?
Let me see, that's 11 metre spacing. So that's your maximum that you can go without putting a movement or construction joint in. Okay. So you've got a choice of how people see all those joints because we've talked so much about gaps and stopping the things we don't want moving through the intertenancy wall. There's 2 ways of doing it. One is to put in PEFROD, compress 30%, and then filling both sides, emphasise both sides of the joint with Sudal firecrel, minimum 10 by 10 bead. The way that most people do it, because of just dollars and cents, is they put mineral wool into that construction joint carefully with a minimum of 10% compression.
Right. No sealant required, just the mineral wool.
There's 2 different ways that people can do it, and that should be thought through because sometimes it might be difficult to get the sealant in to the joint. So the sequencing of their sealing that joint is important, and I have seen people caught out. Okay, thanks for that. From a compliance perspective, what kind of documentation comes with the Masons Enviro IT wall system? As people would expect, we have a design and installation manual. We also have a set of drawings to guide people. There is a record of works, record of installation, which we encourage people to use, and that also sort of a bit of a step-by-step guide that things have been done correctly. The system carries a code mark, certificate of conformity, and those are probably the big ones. Perfect. Okay, thanks. Okay, and wrapping up, where can people go to find more information or get technical support? Go to Mason's website, which is mpb.co.nz. Alternatively, you can search on our website and find your regional representative, reach out to them, be happy to provide support. You can also go to MasterSpec, SmartSpec, or EBOS for detailed information. Great. Well, that's it for today. Even though you don't see them, these walls do a lot, keeping homes safe, quiet and comfortable. Absolutely. If you're working on multi-unit housing or just curious about how these systems work, then the details matter. So check out Mason's guides or call their support team. Thanks for listening, and we'll be back soon with more insights from the world of building and design and keeping building smart. Thanks for listening to the Masons podcast. We hope you've gained some practical insights and ideas for your next project. Be sure to subscribe so you never miss an episode, and visit us at mpb.co.nz for more information on our product systems and solutions. And join us next time as we continue to explore smarter ways and solutions for building in New Zealand.
This podcast is for general information only. While we aim to provide accurate details on building products and systems, Masons is not liable for reliance on this content. Always follow product specifications, manufacturer's instructions, and relevant building codes.